Good morning, dear judges. Today we are going to talk about our smart automatic oximeter. My name is Logeshan.
My name is Harjivan Singh.
My name is Tawnis Rao.
My name is Ayman.
My name is Kamlesh.
Nowadays, nurses has to check patients' SpO2 and heartbeat rate frequently and record in their books. This leads to nurses' work to increase and complicated. Plus, this is also a waste of time for the nurses.
Solution proposal. To overcome this problem, we came out with an interesting innovation, and that is our smart automatic oximeter. Just like a normal oximeter, which measures the blood oxygen level and pulse. But ours comes with some additional feature. The feature is nothing down the patient's pulse and SpO2 with names and directly reports to the doctor's monitor.
SpO2 measurement. Blood hemoglobin is responsible for carrying oxygen. When a person holds a pulse oximeter, light from the device passes through the blood in the fingers. This is used to detect the amount of oxygen by measuring the changes in light absorption in both oxygenated and deoxygenated blood. The sensor consists of two LEDs, which is red and IR, and a photodiode. The oxygenated hemoglobin absorbs more infrared light and reflects back the red light, whereas the deoxygenated hemoglobin absorbs more red light and reflects back the infrared light. The reflected light is measured by the photodetector. The sensor reads these different absorption levels to find the blood oxygen concentration, which is SpO2. The ratio of IR and red light received by the photodetector gives us the blood oxygen concentration.
Heart rate measurement. The heartbeat rate is the ratio of time between two consecutive heartbeats. This change in volume of capillary tissues affects the infrared light of the sensor, which transmits light after each heartbeat. When a sensor is placed in front of this pulse sensor, then the reflection of infrared light is changed between of the volume blood change inside the capillary vessels. This means during the heartbeat, the volume of blood capillary vessels will be high and then will be low after each heartbeat. So by changing this volume, the LED light is changed. This change of LED light measures the heartbeat rate of a figure.
The component and connection are: we use Vimos D1R1 board for our project. It is a IoT processor. IoT stands for Internet of Things. The serial clock and serial data is used to send information for OLED to display. The OLED is powered by 3.3 volt and ground. Then the pulse and SpO2 sensor is also powered by 3.3 volt and ground. The serial clock and serial data is used to exchange data between Vimos processor and the sensor. It is a two-way communication. We use the tech switch to operate our smart automatic oximeter, such as change the mode from auto to manual and execute the reading and etc. And lastly, our Vimos D1R1 board, which has a built-in Wi-Fi, enables it to send the information such as bed number, time, beats per minute and SpO2 to Google Sheet via IoT cloud. Data logging using Google Sheet. We use the Google Sheet as IoT cloud to log the data generated by a pulse and SpO2 sensor. Vimos D1R1 is used to send data to the Google Sheet over the internet. Google script is used and credential need to be set up as the Google script ID, which will be written in the Arduino program. So this is our smart automatic oximeter. So I'm going to power it by using 9 volt battery. So after I turned on, it will connect to my phone's hotspot. Successfully connected, and now it's in manual mode. So I'm going to change the bed number to 601, 602, example 603, and I'm going to start. So this is the sensor that we have to put our finger on. We have to apply some pressure so that we can get some accurate data, and the data is reading now. So I can send the data to my laptop. So the data sent to Google Sheet. So this is the date, which is today, and the time is 4:48. So the bed number I said just now was 603, and my SpO2 is 89, and my blood pressure is 136. So now I'm going to show you the auto mode. So to change to auto mode, you have to press the reset button and the second button simultaneously. So I already pressed the reset button, and it will connect to my hotspot again. So as you can see, this is in auto mode. So in auto mode, it will do everything by itself. So we just have to put our finger and set our bed number, like example So it's already start. So we just have to put our finger here. So if the data is invalid, it will recalculate it again. So the data is reading now. So as you can see here, the data sent to Google Sheet. So I didn't press any button, and this is our data just now. So this is the second data by auto mode. This is the time, and the bed number was 600, SpO2 94, and the blood per minute is 166. That's all from us. Thank you.
Thank you.
Weakness of our product are low cost and local design, compact and portable, user-friendly with OLED display and speaker, and lastly, auto data uploading to Google Sheet.
In conclusion, the project is successful as it produced a 100% working prototype. Future works design and make a compact case by using 3D printing technology. Secondly, auto alert the doctor when the reading passes above the danger level via messages. Lastly, develop an apps to visualize the SpO2 and BPM data via headphone or computer.